I guess as a professor, I guess when we create a test, this sort of like testing ourselves. So, so I guess it's the other side of tests. So I guess you just have to take the test, and I guess we get stuck with having to grade it and pass judgment on different things. So I was mentioning about its last 2 weeks. So he was mentioning that this is the busy time. So I guess that's the time when you have to finish up all the projects. So when is our final project due, project report? Sometime next week?
Yeah, I think so. I'm not positive.
I thought I printed out a couple of these from maybe a year ago or so, just to show you the formatting. So basically it has to be in this 2-column format. So, and you should mention for the title, mention the name of the class, name of the student, name of the professor. And other than that, everything should basically follow a conference format. And so abstract, the introduction, the 2-column. This is the IEEE format. I think I have provided you a template, right?
Yeah.
And so, and your paper should have at least a few charts or diagrams.
Is the requirement still 8 to 10 pages?
That's the suggested guideline.
Okay.
That's, let's see how many pages he has. So he has 8 pages. So that's about right. 8 to 10 pages. But of course, size is not the important. It's not an important consideration. But you have to have at least some diagrams so that you visually illustrate what you are doing. And tables are useful because, and numbers are always good. So sometimes there's just some table with mathematics. Here's a chart. So your paper should be should have some visual components, some equations, and of course properly cited papers. So the citation should be complete, including the page numbers. A lot of times people leave out page numbers, and that is actually a sign that whoever wrote the paper is not an expert. Because having properly cited references, that is one mark of a professional paper writer. But of course, this is of course not a conference, just a class. But since we are doing everything in IEEE style, we might as well have all the requirements. So we were looking at software testing and software reliability. And we have looked at, what are the things we have looked at? We looked at static metrics and defect density. We looked at software reliability growth model and the connection between the two. And what else did we see? We saw how we would compare different models and how to use a model. And we're looking at test coverage and reliability. Coverage and defect found. So not only we want to look at the approach I have taken, I'm not only interested in the components of software reliability, but how they fit together. And I think that is an interesting part of the story. So how do different ideas, how are they connected together? So coverage and defects found, and we have looked at that. We have looked at the model. And we looked at multi-component systems. And there we looked at sequential execution. So basically your software is composed of a number of modules. Each of them are executed sequentially. And we were able to calculate the overall reliability, overall failure rate, and the overall transaction reliability. And then we talked about concurrent execution. Now this is when you have parallelism, when you have a program that consists of several parallel processes. And we looked at the inversion programming. And we saw that it is very attractive. It gives you good reliability. So if you can assume that the failures are statistically independent, then you can achieve a really good reliability. For example, you can have a TMR version. However, it has been noticed, and that makes it controversial. No matter what they do, they have tried different approaches for making failures as statistically independent as possible. But they, for example, they would have different teams work on the same specifications and work independently and come up with an implementation. But they found that there is some correlation. So there are some correlated failures. And there was an analysis by Hatton, which we have seen. And according to this analysis by Hatton, even with the presence of correlation and using the data that some of the researchers have generated using their experiments, you can get an improvement factor of about 50. Whereas if you wanted to do extra testing or do something else, any of the state-of-the-art techniques can reduce defect density by, let us say, a factor of 10. So in some cases, that may be an alternative worth considering. And I have graded your last feedback module, and you will find the grades and comments. And I fixed that typo. So yeah, there was a digit missing. It makes a lot of difference if you have one digit missing in the score. Okay, so I was mentioning about these are the term project reports from before, so just wanted to show you the format. So if you want, before leaving, you could take a quick look at them for a minute. So that's the requirement. So that's samples. Okay, so let's go to the next topic. And, presentations. So since we have a small class this time, this would be a good opportunity to have presentations based on your project. So let us try, okay, how about this Thursday and coming Tuesday? Okay, so who wants to go this Thursday? And for the presentation, let's see. So how much time should we allow for one person? So I think we're thinking of
15 or 20 minutes, yeah.
20 minutes. So the presentations. So these are the project presentations. So about 20 minutes. So that is sort of an upper limit. 20 minutes is actually a fairly good amount of time. So in technical conferences, typically a paper is presented for about 25 minutes. And then you have at least 5 minutes for discussions. And if it is a short paper, the presentation time is typically something like 10 minutes. So 20 minutes is a good amount of time, and you have to skillfully squeeze everything in. And so we will use PowerPoint. Okay, so how many slides you should have for 20 minutes?
120?
Yeah, so yeah, probably not more than 20. So some people have, they suggest a rule of thumb, a slide for 2 minutes. But sometimes in some technical presentations you have a sequence of things in which some of the slides don't have that much information content. In that case, so I would say 10 to 20 slides. So you should have a beginning slide, which should give you the title, and then you need a slide that would include the motivation, and it should also include, or maybe a separate slide, it should sort of give you an abstract, because you need to orient the audience to what you are going to say, so that people will be prepared and they know what is coming. And then you need to go into the main part and make sure that you have at least some visual material. So some diagrams, charts, mathematics, numbers, some visual stuff. And it is probably a good idea to refer to some references. And the convenient way, this is how I do it, would be if you have, this is the slide, and here you have some facts mentioned. So we will put some, maybe some number there or some asterisk there, and briefly mention the paper, maybe a line, and not the full citation, but briefly, maybe a name of the people, the year, and where the paper appeared. So basically, you can say that it is, I think, in research, it is a good idea to give appropriate credit. And so make sure that you say, it is clear in your presentation what, make a distinction between what you are saying about what others have said and what might be your own judgment.
So the Chatham project report is due on December 9th.
December 9th. So
Thursday next week.
So that's Tuesday next week?
Thursday next week.
Thursday next week?
Yeah.
So it's Thursday next week? So you still have some time. And, so okay. So who wants to go this Thursday? That means 2 days from today.
I can go.
Okay, so you can take 20 minutes. Who else wants to go? Okay, so then, okay, who wants to go next Tuesday? So I guess both of you will go next Tuesday. And so one of the persons is not here.